I think many of us look at the standards, and no matter where you are, your standards are fairly like the Common Core. Sorry, if you're one of those states that doesn't think they are. And so if you look at whatever standards you're supposed to teach, I think a lot of us think, I'm a 7th grade teacher, I'm supposed to teach these content standards. Instead, what if our imperative, what if our mandate was to create, to develop mathematicians, to develop students who did the math practice standards, who lived the math
You're
practice
listening
standards.
to today's guest on the Making Math Moments That Matter podcast. It's Pam Harris. Pam is a former high school math teacher turned math consultant living in Austin, Texas. When she's not teaching pre-service teachers at Texas State University, she's out and about leading K through 12 mathematics professional development sessions, writing books, and leading courses.
We're eager to share this fantastic conversation with Pam about what it means to do math, defining the end goal when teaching a concept, discussing the difference between models and strategies, and why math is figureoutable.
I think we are ready to dive in with this conversation with Pam Harris.
All right, let's go.
Welcome to the Making Math Moments That Matter podcast. I'm Kyle Pierce from tapintoteenminds.com.
And I'm John Orr from mrorr-isageek.com. We are two math teachers who, together,
with you, the community of math moment makers worldwide who want to build and deliver math lessons that spark engagement,
fuel learning,
and ignite teacher action. John, we've been waiting for this episode with our good friend Pam Harris for quite some time.
Of course, Kyle, of course. We are super pumped to bring you this episode as always. And you know what is fantastic? Opening up Apple Podcasts and seeing a brand new 5-star rating and review from the Math Moment Maker community.
Just like this 5-star rating and review from MW Math Sci. Always gives me something to reflect upon. I'm so enjoying this podcast. Great variety of shows, and there has been at least one nugget in each show that really gets me reflecting on my own practice. Even after 3 decades in the classroom, I like to see what I can do better. That sounds like a typical math moment maker over there, John. MW Math Sci, thank you so much for leaving us that 5-star rating and review on Apple Podcasts.
Yes, Kyle, we want to thank to our fantastic math moment maker community like MW Math Sci, who took the time to help ensure the podcast reaches the ears of more math teachers around the globe.
Well, my friends who are listening at home, go ahead. What are you waiting for? It only takes a minute to fire us an honest rating and review. Grab that phone, pull it out of your pocket, and go ahead and do it right now as you're listening. It means so much to us.
Also, you're clearly interested in getting kids leaning in to learn during your math lessons with the goal of building of conceptual understanding, number fluency, and flexibility.
Well, how do we know? Well, you're listening to a math podcast, of course. Want to take a deep dive into the Make Math Moments 3-part framework? You can download our 3-part framework guidebook by visiting makemathmoments.com/framework.
In this downloadable ebook, you'll be able to take the learning with you and build your own understanding of how you can spark curiosity, fuel sense making, and ignite your teacher moves in all of your math lessons.
Go ahead and grab it now by visiting makemathmoments.com/framework. That is makemathmoments.com/framework.
Okay, now on to our chat with Pam.
Hey there, Pam. Welcome to the Making Math Moments That Matter podcast. We're super excited to have you on the show today. How are things on your side of North America?
Hey, Kyle and John. I'm thrilled to be with you guys. Thanks for having me. Things here are cold at the moment, but we're doing well.
Awesome. That is fantastic, Pam. You know, we've met a number of times, but like always, we'd like you to just fill our listeners in a little bit about yourself. It's possible that they might not know who exactly you are. So could you fill us in a little bit about your role in education, where you're coming from, and how did you get into teaching and education? Fill us in on a little backstory for us, please.
So at the moment, I'm in Austin, Texas. I teach at Texas State University. But honestly, what I do the most is a lot of professional development. I work with pre-service teachers at the university, but I do a lot of in-service professional development with teachers around the country. Keep hoping to get to Canada one of these days.
We'd love to have you up
come
here.
on up.
I do a lot of work K-12. I began as a high school math teacher. I had a great time teaching high school. I loved teaching juniors and seniors. They made me happy. Freshmen made me slightly crazy. I really enjoyed teaching. I'm going to date myself just a little bit. When I began teaching, graphing calculators had just come out. And in my student teaching experience,
The TI-83s?
TI-81s.
Whoa.
Ooh, I was going to say maybe, yeah. Well, if it was the first one, would it be like the TI-1s or something like that?
Did try. No, actually started with the 81. The very first one I used was at the university. There was an HP calculator that my professor said you could use it if you wanted to, but you didn't have to. We were at a complete disadvantage, those of us who were taking linear algebra who didn't have it, as my boyfriend at the time actually had one. He took about 38 minutes on the first test, and I took 3.5 hours because I did all the computation by hand. Anyway,
geez.
So
you probably got more out of it though, right?
So let's talk about how to teach with technology. If you're going to teach with technology as a tool, you have to be aware of the assessments that you give, because you could definitely put students at an advantage or disadvantage, especially if you give them a choice whether they're going to buy that expensive tool or not. So because I landed in my student teaching, Pam Giles was an amazing teacher. She was one of the very first teachers who'd ever taught with graphing calculators. She went back to the Ohio State University with Frank DeManna and Bert Waits. They were the professors that were sort of the grandfathers of graphing calculators, and really learned how to teach math using the power of visualization. I give her a lot of credit for my beginning years as a teacher. So in a huge way, that student teaching experience flipped everything on its head, and I learned there was a better way to teach math than the way that I was taught. I could play with the math. I'd never heard of a parent function before. I'd never heard of transformations. And all of a sudden, I could put a trig function in there and I could mess around with the parameters and I could see what happened. It was so much fun to just play with the math. And it really opened up my experience to a different way of thinking and reasoning about secondary math. So I'll tell a short version of the story. I had 4 kids, my own personal children. And when they were growing up, I was fascinated by the kind of math they were doing. We just messed around with numbers a lot at home. We baked together and counted a lot and played some math games. And my personal children were just messing with numbers in a way that I never really had. And I just became really fascinated by it. The short story is I started volunteering in their classrooms because I noticed that the math they were sort of doing with me was really interesting and exciting, and they were really thinking and reasoning, but they were bored in school. I knew that there was a better way to teach secondary math. I learned that with graphing calculators. I began to wonder if there was a better way to teach arithmetic. And so I volunteered in schools, dove into the research about how we could teach arithmetic better, and learned that indeed there is a better way that we could teach kids to really have powerful numeracy. And I give my own personal children a lot of credit for that. So I learned that, like I said, I volunteered in my kids' classrooms. Over a period of about 5 years, I kind of took over my kids' school. I did all the professional development with the teachers, K-5. And then as my kids grew up, I did the professional development K-8 in my kids' district. We had about 13 elementaries. And honestly, we made a lot of mistakes. We sort of dove in and tried some things that as a secondary teacher, I thought, everybody must know this stuff. But what I didn't know is I had landed in some research that was really quite new. And so we tried a bunch of stuff, learned a ton of things. At that time, I had been working with Texas Instruments because of my cooperating teacher and graphing calculators. And so I was also doing PD around the country, teaching teachers how to teach high school math better with graphing calculators, while I was really building my own numeracy. I was learning that I hadn't had any numeracy. In fact, sometimes I'll joke a little bit that I had negative numeracy. And so when I was doing the PD with graphing calculators at break, I would say to my fellow secondary teachers, hey, did you know you can actually think about subtraction? And they were, for the most part, surprised and intrigued and kind of interested. And teachers began to tell me, we would go to a workshop on that. So I kind of began to give my own workshops on building powerful numeracy. Some of those beginning workshops, I look back and man, I really didn't know I would ask teachers a question. I would say, okay, how would you solve this problem? And then I would really have to think to be able to understand. And often now I use a PD move, a teacher move, where I'll ask people to restate someone's strategy, or if somebody could explain some, if Kyle had given a strategy, I might say, John, could you explain Kyle's thinking, or could you restate his thinking? But in the beginning days, I had to do that just so I could understand Kyle's thinking. I had no idea really what people were doing. I was literally building my numeracy along with people at the same time. And so in that work, I began to basically spend about the next 15 years traveling around the country talking about building powerful numeracy. And so I wrote a couple books, did tons of workshops for numeracy. And I'll just kind of finish up my story a little bit by saying that about 8 years ago, I turned my attention back to secondary math. And I realized that there were some things that I'd learned in building and teaching numeracy that I could actually apply in teaching higher math. So it wasn't, when I was talking about building powerful numeracy, often the workshops I gave for secondary teachers were, if we could build some numeracy in your secondary students, then look how that will help you teach the content that you're actually supposed to teach. We do a little bit of subtraction into the slope formula. Wow, kids actually understand that it's the difference, that subtraction sign in the slope formula has everything to do with the distance between those y values, and the distance between those x values has nothing to do with takeaway or removal. And so I was doing all this numeracy work into high school content or middle school content. But then I turned my attention back and I actually realized that there were some things I'd learned in teaching elementary math that I could now apply in teaching secondary math, like lesson structures, ways of teaching, ways of interacting with students, so high leverage teacher moves. And my favorite lesson structure that I learned is kind of the one that I champion now. It's called problem strings. A lot of people think they're like number talks, and they have some elements that are similar to number talks, but in a huge way, they are, I think, the inroad for teachers. I think if teachers are interested to change their practice more towards real math and the thinking and reasoning using relationships, what I call real math, I think problem strings could be the place for teachers to start. And so for the last few years, I've really worked hard on writing problem strings for middle and high school teachers, for really with like high school content, algebra problem strings, geometry problem strings. And I've also worked really hard K-12 on sequencing tasks. So that's another interest of mine, is how can we take things like problem strings and number talks and rich investigation, rich tasks, like 3-act tasks, and how can we sequence them? I think rich tasks are cool. I think number talks are neat. But I think really when we can put them in concert with each other, when they work together, that's really where the power comes in, and we really can help students develop as mathematicians.
That is quite the story. I've taken down some notes, and I know through our conversations and actually recently spending some time at NCTM Regional together and having a chance to really sit down and grab a bite to eat over lunch and just chat about math, I see so many of the same experiences you're describing that have been happening to me, maybe more recently, because again, folks who are listening, they know John and I both came out of the secondary classroom. John's still in secondary classroom, and I'm geeking around K-8 a lot. And even recently, we just did some workshops last week. And when you bring up this idea of takeaway or removal subtraction versus the difference or the comparison subtraction, we actually did a Kathy Fosno mini lesson with our PD group highlighting that, and just in how sometimes even the values we're working with will sort of like lend to certain strategies, and this one particular mini lesson was really cool. For those who are listening, if you were to think about how you would subtract 74 subtract 6. If you think about 74 subtract 6, typically what people tend to do with that is they tend to think of it, if it's no context, right? If the context is there, then you sort of tend to ride the context as to whether you're actually taking away or you're doing the difference. But in that case, people tend to take away because you're only taking away 6. It's like, it's pretty easy to do. I could take away 4 and then 2 and boom, we're good to go. But then when we look at larger numbers, when we're subtracting like 86 minus 78, while you can take away 78, it's a lot more work. And what people tend to do, not everyone, but what people tend to do is when the numbers are closer together, they tend to think of it as a comparison or a different subtraction versus a removal or takeaway. And a colleague of mine, Yvette Lehman, she says she has to like deprogram her son who's in kindergarten because he thinks subtraction, when he sees that symbol, he thinks takeaway. And there's actually more than 2 types of subtraction. You can also think about missing addend and missing subtrahend problems as well. But for him, he thinks everything's takeaway. And in reality, there's this whole other world of comparison subtraction, or the difference, finding the difference between two values. And for me, that really resonates. And I'm hoping we can keep diving into your journey here. I think I'm going to really geek out on this one because I realize as well, I had very little. I love your expression of negative numeracy. I had very little. I was a memorizer, and I mean, I could calculate whatever you threw at me, but I didn't really have a strategy. I couldn't articulate my strategy. So I think we definitely connect on that level. So before we go any deeper, though, I want to go and dig back. You've given us an inside scoop as to your own professional learning journey as a mathematics educator and now consultant. I'm wondering if you can roll back to your experience in math class. Is there a memorable math moment that sticks out for you when you think back to math class?
You bet. I've got a couple, but I'll share this one with you. I was in 7th grade. I had, no friends. I looked around and I thought, I'm good at math. I'd always been good at math, which for me at that moment meant I had been quick. I memorized well. I sort of won around the world in 3rd grade. I was the first to do long division in 4th grade. I didn't really know what I was doing. I definitely couldn't articulate why I was doing what I was doing, but I was able to mimic the teacher well, what I now call fake math. I sort of knew I was good at that. And I looked at the math club. There was a math club that met, didn't know before. I thought that's a place I could go belong. Sweet. Maybe I could find some people I could fit in with. I'll go to the math club. So I went to the math club. The kids were already sort of working on some things. I sat down. The coach handed me a piece of paper with some problems on it. I looked at the first problem. I'd never seen the first problem. I had no idea how to do it. So I skipped the first problem, went to the second problem. I was seeing a pattern. I didn't really know how to do any of them. I knew how to play the game. I know what you do in math class. So I raised my hand. Coach came over. I said, hey, you know what? I've never seen these problems before. If you wouldn't mind, if you could just teach me how to do these, then I'll happily, solve them correctly. And I know how to play the math game. And he smiled at me and he said, that's not what we do in here. We just sort of use what we know. We kind of play around with the numbers, and we solve the problem. His description of what I was supposed to do to solve those problems was so foreign to me. It was so different than my experience in sort of school fake math. I didn't know what to do with it. I kind of looked around the room. I was so uncomfortable. I stood up, walked out, never came back. I just put it out of my mind. I thought, well, whatever that was, I didn't understand. They're weird. And I literally just didn't really know what to do with it. So I kind of just ignored it and went on with my life. It's so interesting for me now to look back on that experience and realize why that was so different for me. And what I could have done in that math club really was just think and reason and use what I know. But in a huge way, I wasn't able to hang on to relationships until, and I'm going to give a lot of credit to Kathy Fosno and her Young Mathematicians at Work crew. You mentioned earlier that you guys were using a mini lesson from her work. When I mentioned that I dived into elementary research that had just come out, in a huge way, it was her stuff. And reading a lot of the research that she and the Freudenthal Institute had put out, a lot of it is based on the idea of making thinking visible, of helping students take up thinking because they're using powerful visual models to represent the relationships visually. I had teachers before. Here's another memorable moment for me. I was in 8th grade and we had just learned how to FOIL. So we were doing, linear binomials times each other, multiply by each other. And the teacher had taught this FOIL thing. Well, then she was absent the next day and I had a substitute. Mrs. Newbern, I will never forget, said to me, hey, she kind of knew that I liked math. She said, hey, you could use this distributive property that you're doing. You could use that to multiply, numbers together. and I looked at her and I was like, whatever, weirdo. I don't know what you're talking about. I remember that moment because she was so excited about it and I had so little access to what she was talking about. I knew that math was about memorizing. It was about mimicking the teacher and spitting stuff out. And so when she tried to tell me another way to get an answer, I had ways to multiply. I knew how to multiply. I multiplied well. I multiplied with the best of them. And so when she says, you could multiply whole numbers using this other strategy, to me, that was like, I've got a way to do it. If math is all about rote memory, then I kind of am trying to shove it all in my head. If you could see me right now, I'm like plugging my ears because if it's about rote memory, why would you give me extra? That's mean. If I have one way to do it, don't try to put more in my head. It's going to start leaking out one of my ears. I can only hold so much in there at a time. What I didn't realize is what mathematicians do. Mathematicians use what they know. They use the relationships among the numbers. And in a huge way, I was finally able to start doing that when those relationships became visible, when I could start seeing an open number line and I could put numbers that I needed to mess with on the open number line. And I could say to myself, what are friendly numbers near these numbers that I could use? Or an open array, an area model, if I was going to work with multiplication, that I could really sense the chunks of numbers that I'm dealing with. Area. The area to me as a student meant, wait, is that the one where you multiply or you double and add? Because I had completely known that there was finding perimeter and there was finding area, and I just needed to kind of remember which formula was which, and then I was done with area and perimeter. Oh, but I could actually use an area model to really think about relationships with multiplication. And by doing that, then I built my multiplicative thinking. And building my own multiplicative thinking just opened up the whole world of proportional reasoning and functional reasoning that I could actually use other relationships to solve more and more complex problems. The more relationships I was able to take up because they were made visible, the more then I was able to use to solve other more complex problems.
It's so funny because you're trying to memorize all of this stuff. Like, I totally can relate. And I find that there's a lot of students that we tend to consider to be quote unquote math people. And they have that same perspective as well. And it's likely that they just got kind of lucky that they're able to memorize things without actually having a connection. Like, they have that rote memorization and they don't necessarily have that automaticity, like actually being able to reason and problem solve and actually use it for different problems that they haven't seen before. And, you know, it really reminds me of what we might hear when a teacher shifts from this traditional method of teaching, like essentially more of a traditional style that maybe most parents and folks at our age actually experienced as students. We tend to hear things like, the kids, I don't understand this new math. I don't get what they're doing. They're complicating things. Like, there's even videos on social media where I saw one recently. It was like side by side of a teacher trying to show connections with multiplication with the area model. And then on the right, a guy's using the standard algorithm and he's done in like 13 seconds. And then it shows him like cooking things in the microwave and like doing all this other stuff. And really just basically giving this impression, like you had said, that it's like, my only job here in math class is to gobble up all of this information and regurgitate it. And I can't actually take on anything additional. And actually, in that sort of learning environment, I would agree that actually they would get confused because they don't understand what they're doing anyway. So, you know, I'm wondering, what do you say to a teacher who has that? I know what I might say, and I know, John, you've had this discussion before too. Like, what would you say? What would Pam Harris say if, let's say, a teacher you're working with in PD is saying, I'm fearful that a parent's going to push back on what I'm doing and that their kid's getting confused. And it's often like a frustrating sort of experience moving from that traditional model to a more conceptual model. I'm wondering, like, what are your thoughts on that? And how might you help someone who is trying to ditch that procedural rote memorization without connections sort of method to something more conceptual with connections and reasoning and problem solving?
Yeah, you bet. If I could actually first talk just a little bit about that social media video that many of us have seen, I actually think one of the problems with that video is less sort of the guy on the right who does the algorithm and then goes and gets a cup of coffee and puts something in the whatever, all the stuff that he does. But actually, the thing that's on the left with the area model is actually, if it's the version I saw, is also fake math. It's someone who's using the area model in a very procedural, step-by-step way. I actually just saw a tweet today where someone was sort of saying, yay, look at how I'm doing conceptual stuff in my math class. But when I looked at the pictures that were in the tweet, I saw a student multiplying 7 times a 2-digit number, I don't remember what it was, but had drawn a 4x4 square and had written 0, 7 as the dimensions on one side and then whatever the other two. In other words, the student sort of splitting by place value, memorizing this way to use more of a graphic organizer instead of actually, what would a 7 by 23 look like? Well, it wouldn't look like a square, for heaven's sakes. It should look like, something short, 7 by something much longer, 23. And then why would I ever consider 0 plus 7? That's a 2-chunker. That's a 7 by 20 and a 7 by 3. I could add those together. So whenever I see somebody using an area model as just another procedure, another thing to memorize, and a good clue is if kids have written 7 as 0, 1 dimension 0, 1 dimension 7, then I'm also going to push back against that. It's not about the model. One of the things I try really hard to help parents and teachers understand is that it's not about the open number line. It's not about the open array. It's what we're doing with them. If I say to a student, hey, how did you solve that addition problem? And the student says, I did a number line. Then I'm going to smile and I'm going to say, what did you do with the number line? What numbers did you use? How are you using relationships to solve the problem? It's not about the number line. Often we'll ask students how they did a multiplication problem. And they might say, I did a ratio table. To which, again, I'll sort of grin and I'll say, what did you do with the ratio table? So differentiating between models and strategies and helping teachers realize that there's a difference between those two is one of the most important things that we need to help teachers who want to take that jump that you're talking about. We need to help them understand it's not about just taking a new picture and applying now a new set of rules to a picture. I mentioned earlier that the visual representation is important, but the visual representation should be of the relationship students are using, not of just another set of memorized steps. So another thing that I think is really helpful in this conversation is the difference between a strategy and an algorithm. I just actually talked to a fairly highly respected secondary PD person the other day in Salt Lake, actually, not too long after I talked with you, Kyle. And he said something about, well, if a student creates their own algorithm, they use the relationships and they've sort of created their own algorithm. Well, I'm going to pause right there for a second. Students rarely create an algorithm. So let's define algorithm and strategy real quick. An algorithm is a series of steps. It's a step-by-step procedure that's designed to solve any problem in the class. What that means is it's a generalized procedure. It's all the steps all the time. It is the thing that computers must have. Computers have to have algorithms because they have to just shove the numbers in and do all the steps all the time because computers cannot be judicious problem solvers. Computers can't look at the numbers and let the numbers influence how they're going to solve the problem. For example, if I were to add 99 plus anything, I don't know, pick an ugly digit, a 2-digit number, 99 plus 47. If we were going to add 99 and 47, a computer would line those numbers up just like we all learned in first grade, would work with the digits first, would regroup the numbers as they go right to left, small to big, because a computer has to do that. But if you get anybody with numeracy or any kid before we've sort of ruined them by stressing the traditional algorithm, if you ask any kid 99 plus 47, a lot of people, when I do that 99, I sort of activate some prior knowledge. I activate this idea that you're inclined to go 99, 100. Well, if you're thinking about 99 and 47 as 99, 100, well, what do you still have to add? You were supposed to add 47, but you've already added 1, so you still have 46 left. Now, I really wish I was showing this on an open number line so we could hold on to these relationships better, but 99 plus 47 simply becomes 100 plus that leftover 46. Well, 146, that's pretty doable. That's an example of a strategy. A computer's not smart enough to choose to do that strategy. That's far more efficient than using the traditional algorithm to add 99 and 47. And let me go a little further. An example of the traditional algorithm for multiplication, if we were to do 99 times 47 for multiplication, we would have to do all the steps all the time, including the magic zero and all the addition and all the things. And it would take quite a few steps to do 99 times 47. Let's activate that prior knowledge one more time. 99, 100. Could you think about 99 47s as 100 47s? Well, if I've got 100 47s, but I only want 99 47s, I just need to get rid of 47. So now I need to know something about 4700 minus 47, and we're maybe back a little bit to what we were talking about earlier with subtraction and how important subtraction is to really understand and be able to feel. A quick story. I was actually at a math conference several years ago. The math focal points had just come out. Not a lot of people recognize them because they were kind of short-lived. We didn't do a lot with them here in the States. But NCTM at one point had funded the writing of the math focal points. And one of the authors was a good friend of mine. And we had just never had this conversation. And so in the middle, she'd given a presentation on the math focal points. And in the middle of the presentation, they had a question and answer. And I raised my hand and I said, my question for you is, why did you put so much emphasis on the traditional algorithms in the focal points? And she glared stared at me from across the room because she knew I was bringing up kind of a hot topic. She gave a fine, sort of politically correct answer, and then we were done. And she came up to me after the session, and she was, a little frustrated with me. And she said, "Why did you do that in front of everybody?" And I said, "Because I really want to know. Like, I'm actually really interested. Why are you putting so much emphasis on the traditional algorithms?" And she said, "Well, Pam, you're secondary. You know as well as I do that there are times where you just want to do the quick and dirty thing to get the answer." To which I replied, 99 plus anything? 99 times anything? And I'll never forget, we were kind of walking down the hallway in this very busy math conference, very busy hallway, all these people, and she stopped. Several people ran into us, like piled up in the hallway. And she looked at me and she said, "Is that what those people are talking about?" I thought that was so interesting that here we had a university person who was an expert in her field who actually didn't even really realize what a lot of us have been talking about when we advocate children learning and developing alternative strategies. It's not because we have some weird goal of just like getting them to kind of understand some things and then the goal becomes the algorithm. And here's maybe where I differentiate myself from several people that I think are really good out there that are trying to accomplish really good things. And I would differentiate my work from, like I said, lots of people that are doing good things, good work, really good work. If I describe their work in a huge way, they're advocating that we help students understand conceptually what's happening with place value and numbers and relationships so that the students can then understand the algorithm better. But their end goal is a traditional algorithm. They do all the learning and the thinking and the reasoning and the trying to help kids really estimate and get better at the relationships. But their end goal is still that kids then get good at a traditional algorithm. Not my goal.
What is your goal then, Pam?
So my goal is that I help kids become mathematicians. Now, when I say that, I pause a little bit because I realize that there might be people out there that say, Pam, I mean, maybe your students are becoming mathematicians, but you don't know who I'm teaching. You don't know my population. They're not becoming mathematicians. I might have, maybe 2 or 3 students that might someday become a mathematician. But caution, I don't mean mathematicians to be. I want to mentor mathematicians in the here and now. I want my students to mathematize. I want them to actually do the work that a mathematician does at their grade level. So if I'm working with freshmen, I want to have 9th grade mathematicians. Sort of like when we teach kids to read, kids read. When we teach kids to write, they write. When we teach kids to do math, they
calculate.
We don't have a verb for that, right? So Kathy Fosno coined the verb mathematize. And I think mathematize means what a mathematician does when they are doing their mathematization, when they're mathematizing, when the part of their brain that lights up when they do their work. That's the part of the brain I want to light up in my students. I want them to be thinking and reasoning using relationships and connections they own. That's my definition of real math, not fake math. My definition of fake math is a disconnected set of facts to memorize and rules and procedures to. In fact, if I can just add one more quick thing. Often when I talk to teachers or when I hear teachers, they'll say, "Hey, show me your work. If you show me your work, I will give you partial credit."
Show me the steps that I
show me
outlined.
My work you can remember.
Yeah, mimic me. I have given you the rule in the box. I've clearly shown you the steps. We've worked 3 worked examples, and now it's your turn to go do. And if you will mimic my steps correctly, I will give you partial credit. Well, that's not what I'm after. I'm not after them mimicking me. I'm after them learning the major strategies for each of the operations. This also differentiates me, I think, from a lot of people's work is I've identified what I think are the major operations that students need to know for each of the major strategies students need to know for each of the operations so that they can solve any problem that's reasonable to solve that a calculator. They can quickly use one of those sets of relationships, and most of the time, they will be more efficient than the traditional algorithm. Every once in a while, I'm as efficient as a traditional algorithm. But you know what? I'm never less. I am never less efficient than a traditional algorithm. And most of the time, I'm more efficient. But even more important than that, I'm mathematizing. Like I'm actually using my brain and relationships to do what mathematicians do. It's so empowering to know that I can think and reason using what I know, what I actually own. I'll take a breath. What are you guys thinking about?
I'm just going to throw in a quick comment here. These big ideas that we're talking about right now come down to what you just said a moment ago about what you want your students to think about math. Like most teachers think like, what is doing math or what is being good at math mean? And so many of us just think like, math is calculating, math is getting answers and not memorizing and like just doing the homework. Like we've talked about it here on the podcast before, that math is like the do subject. It's like we're supposed to just do this and then move on to the next thing. And, there's such big ideas here to think about. If we have a view of math as a just do subject and get done subject, or do we have an idea of what you've said and suggested? Are we creating mathematicians? Is math about problem solving and thinking about strategies and coming up with their own strategies and becoming mathematicians? It's a huge idea to think about, and it's such a huge mind shift that we have to help other teachers other teachers learn, because we were those teachers I was that. Show me the extra credit. Show me the steps. Let's get all this done and we'll move on to the next piece. So it's a huge mind shift for us to switch gears and think about math is not just getting these things done and memorizing and doing math questions, but actually having our students develop strategies and use their own strategies or mathematize. It's a huge thing that we're talking about here.
I can't help but go back to this image in my mind when, Pam, you had mentioned this idea of like mathematizing and the part of the brain that, is working. And on the other hand, I'm picturing like, do we want the part of the brain that's working, like the long-term memory only, like retrieval, like that regurgitating? And you had given some examples of the 9900 scenarios there and what strategies students might use. And like another big one that immediately popped in my mind was 1001 minus 999, right? Like talk about a complete mess that is, if students literally are like, well, the only way I know how to subtract is to line them up. If I line them up wrong, then I'm toast. If I line them up right, if I borrow and I do something wrong here, I'm going to do a lot of.
I can remember the 9 versus the 0, right?
Like that one's
the 0 sometimes and a 9 sometimes.
That one's such a doozy, and it just immediately popped into my mind when you said 99 plus whatever. I was like, yeah, like it's 2 apart. Like it's so close. It should pop right into your head. And something that happened to me actually today as we were sharing we had kind of like a monitoring assessment that we're going to be doing, like a handful of questions in our district to try to get a better sense as to where students are struggling with certain topics and like we're routinely struggling with them. And we had shared a problem, and we actually had a room full of administrators, and they're all great people, and we're all on this learning journey together. And something that really hit me and relates so closely to this conversation was when an administrator read the problem and then bravely shared in the room that like the problem had the word difference and it had the word total really close together. And right away, the administrator had said, like, that's probably why students are struggling. And like right away, I addressed this very thing, is that because students are looking for keywords, so I guess my question, and I didn't state the question because obviously it wasn't the appropriate time, but my real question, my real wonder is, so what should we work on then? Should we work on changing questions so that keywords will still work for students so that they can solve them? Or do we work on getting kids to become mathematical thinkers, to be able to mathematize this scenario? And if you actually look at the context of that problem as a whole, there was no doubt, there was no mix up as to what it was that they were having to do. And if they had that visual, as you mentioned, the scenario would have been perfect for a number line, and it was not a difficult problem, but it was immediately going right for those keywords. And then finally, I had this one on the tip of my tongue for a while, was talking about this idea way back to that video on social media, where what I see a lot of times and what you hear a lot of times as teachers start to begin shifting to a conceptual sort of approach, they tend to still think in that I'm going to show you approach. So it's I'm going to show you the area model versus Kathy Fosno, I know you know this, is this idea of emerging models, right? So through student strategies, we're going to actually emerge models. We're not going to say today, we are going to uncover the area model and here's how you do it. And yeah, here it is. And you're going to set this up. And that's such a hard shift for educators to actually wrap their heads around. I'm sure you've probably got a bunch to say about that as well.
Yeah, absolutely. So one of the things that I would share with teachers and leaders that are trying to make that shift, one way to think about it, I really wish I could remember who I'm quoting. I heard this about 6 months ago, and I honestly don't remember who said it. So if anybody knows who it was, please shoot me an email. I'd love to be able to give them credit. But basically, the idea is that I think many of us look at the standards, and no matter where you are, your standards are fairly like the Common Core. Sorry, if you're one of those states that doesn't think they are. And so if you look at whatever standards you're supposed to teach, I think a lot of us think, I'm a 7th grade teacher, I'm supposed to teach these content standards, and I'll teach them using the math practice standards. So my job, my goal, my imperative is that I need to teach these content standards, but I'm going to use the math practice standards, try to get my students to do some of those math practice things as I teach my imperative. I wonder about flipping that on its head. Instead, what if our imperative, what if our mandate was to create, to develop mathematicians, to develop students who did the math practice standards, who lived the math practice standards? If we develop students who really were reasoning abstractly and quantitatively, and they really were making sense of problems and persevere in solving them, they really were modeling and using tools strategically and attending to precision and looking for and making use of structure. If we really had students doing that, oh yeah, that's my imperative, my mandate. And how do I do that? Well, I'm a 7th grade teacher. I'll use the 7th grade content to do that. Or I'm an Algebra 1 teacher. I'll use the algebra content to do that. Or I'm a 3rd grade teacher. I'll use the 3rd grade content to do that. If our mandate, our job, the thing that we really were focusing on was helping students do those math practice standards, become mathematicians. And how do we do that? We'll use the content that's our grade level or it's our subject. Maybe I'll use geometry because I'm a geometry teacher. I'll use that content to help my students become mathematicians who use those math practices. That's a little bit of an interesting shift that I wonder if that might help some people realize more what we're going for.
For sure. It's for most teachers done the opposite way, right? It's kind of like I have my content standards to teach, and then I got to make sure I throw in an activity that gets kids to reason or communicate ideas and those kinds of things. So I think that would go a long way. And I think the teachers who have figured that out, Pam, are making the bigger difference in their students to get them to become those mathematicians and getting our students to actually think about math class. And then that makes the math moments matter for our kids. And I think those are the moments that kids actually start to remember about math class that are positive. It's like you're going to get that kid later on, 5-10 years from now that says, you know what, I had a teacher that cared more about my learning than, say, the content standards all the time. And I learned so much about just solving math problems. And I think that's what we're always gunning for. And that's partly why we've created this podcast and we've created our website and all those things we're trying to help change. And I think that's a great way to look at it for sure. I want to keep going down this path because we've been talking about so many huge ideas in mathematics and in mathematics education. And another one I think can come out of this is when I read your website, even just the title, like mathisfigureoutable.com, which is a great name for a site. We were curious about where did you come up with this title? And then also, if you think about somebody who has those negative mindsets about math education, how do you believe or use the ideas that we've been talking about to help change some of those beliefs of how kids and also parents think about math? And it's actually truly figure-outable. Can you just comment a little bit about the website name and where that came from?
You bet. So often when I introduce myself, when I'm giving a presentation, I'll start with math is figureoutable. And then I'll pause and I'll kind of chuckle a little bit and say, of course, we all believe math is figureoutable. We're all here in a math teaching workshop or a math conference. So haha, we all think math is figureoutable. However, I'm going to admit that as a student and far too long as a teacher, I actually believed that math was rote memorizable. I believed it was a disconnected set of facts to memorize and rules and procedures to mimic. And I was good at that. So I liked kids and I wanted to teach and I went into teaching because of that. But now I have this whole different perspective on what real math is, using relationships and connections you own to solve problems, and in the process, creating new math for the learner. That math really is figureoutable. And when I start a workshop with that sort of math is figureoutable mantra, it's interesting. Usually somewhere around halfway through the day, someone will say, wait, something must be off. I'm really having to think here. I thought you said math is easy. Which I'll chuckle a little bit and I'll say, oh, hang on, I didn't say math is easy. What I said is math is figureoutable. Yeah, it might take some thought. Teachers sometimes will push back and say, Pam, I could just quickly do that traditional algorithm and I could get that answer. I wouldn't have to do all this thinking, and my brain's really having to work to use these relationships, and I'm really having to put some mental effort into this. And I'll smile and I'll say, well, okay, so let's just be really clear. What's your goal? Is your goal to build your brain as a mathematician? Well, then I'm going to ask you to do some figuring. Math is figureoutable. I'm going to ask you to put that effort into it. Oh, what you're saying is you just want to get a quick answer without having to think? Is that what you're saying? And people will sometimes smile and say, yes, I just want to be able to do that algorithm because I can do it really without thinking at all. I actually had a woman tell me once, Pam, I can listen to you and I can multiply 2-digit numbers together and I can totally hear what you're saying and not even put any thought into multiplying those. To which I reply, okay, if your goal is to get an answer without thinking, you know what? Let me hand you your cell phone calculator. If that's your goal, if your goal is to be able to do something without thinking, then why not use technology? If you were an employee in a store and you chose to do something by hand where you could have done it with technology, you ought to be fired. I mean, there are times where technology really is a tool for us. So I want to teach judicious use of graphing calculators or of calculators at all, of technology. Teachers often find it kind of interesting to note that I, on the one hand, do workshops on how we can use graphing calculators well, and on the other hand, I give workshops on mental math. Because mental math, and I'm going to quote Kathy Fosno here, mental math does not mean that you do it all in your head. Mental math means that you do it with your head. Let me say that one more time. Mental math does not mean you do it all in your head. Mental math means that you do it with your head. So if you're doing mental math and you need to keep track of what you're doing to be able to sort of use those relationships, it's totally legal for you to write down a couple numbers or draw an open number line or whatever to help you kind of keep track of the relationships. Totally legal. But if you're doing something in your head that's a memorized series of steps and you can keep track of all those little ones and crossy outies, not mental math. Even if you didn't write anything down, that's not mental math. You weren't using what you know to solve the problem. You were mimicking somebody. That's not mental math. That's just mimicry. I'm not after mimicry or robots. I'm after creating, developing mathematicians.
Absolutely. Absolutely. And, John and I, we get this so often when we get new strategies. It's like trying to be told how to do something instead of actually figuring it out. Like when you're actually in the workshop, I think one of the biggest challenges, and this happens too with our students who are comfortable with the game that they've been winning so far, right? We've actually been allowing them to supposedly believe that they're winning the game of math because they've been blessed with like a really, really good ability to recall. And in reality, when we start to push them out of that comfort zone, it's like all of a sudden they have no armor, right? It's like, oh man, I'm not the fastest in the room anymore, or I don't just know the answer right away. It's like I actually have to do some thinking. And for me, I think that problem solving process in our classrooms, like there is so much benefit from doing that work. And I look back to my own teaching in my own classroom. I had calculators out all the time in secondary math, and then I would still complain that kids had no number sense. Well, at the same time, while saying that, I had no idea that I actually didn't have any number sense, like you had cited earlier. So I know you've been talking recently all about the development of mathematical reasoning recently. We can't go too deep into it. I know we're going to be running out of time soon, but I do want to give you an opportunity just to kind of share why that is something that is so close to your heart. And I'm going to give a little bit of this cat out of the bag here because John and I focus so much on this very same idea of mathematical reasoning. So I'm wondering, do you mind sharing, like, what is this development of mathematical reasoning? And maybe where could they learn a little bit more about it if they want to dive deeper?
You bet. You can learn about almost everything we're talking about tonight more on my blog at mathisfigureoutable.com. And I have several blogs on the development of mathematical reasoning with some videos on my YouTube channel. But in brief, it is a graphic that I created to talk about how counting strategies lead to additive reasoning, and that leads to multiplicative reasoning. And all of these are embedded within each other. And multiplicative reasoning leads to proportional reasoning, which is embedded within functional reasoning, which I don't love that name. I wish it was more about, because it's not just functions, it's also relations, but it's that big idea of how we can really think and reason about functions and relations in high school math. And one of the main purposes for having this sort of nested set of kind of domains is to help teachers understand that whatever their imperative is, let's say that I'm a third grade teacher, then I would suggest that their job is to really help students develop additive reasoning into multiplicative reasoning. If that's that particular teacher's place to be, then what we don't want to do is let them get answers to addition problems using the less sophisticated counting strategies, or get answers to multiplication problems using the less sophisticated additive reasoning. So for example, proportional reasoning is more sophisticated than multiplicative reasoning. So when we, as middle school teachers, are supposed to be teaching students to be reasoning proportionally, what we don't want to do is let them solve proportions using only multiplicative reasoning. We need to actually be helping them develop their brains to be reasoning proportionally. So all too many middle school teachers are, and too many textbooks and curriculum and the whole thing, teach students to solve proportions using cross, multiply, and divide. Well, if you think about cross, multiply, and divide, that's multiplicative reasoning at best, if they're even reasoning when they're doing algorithms to cross, multiply, and divide. And that's the reasoning from the level before. So I'm getting answers to a particular kind of problem, but I'm using reasoning before. That can't happen. We need to have teachers realize, if this is the kind of reasoning I'm supposed to be developing in students, then I want to actually develop that reasoning, not allow them to get answers using less sophisticated reasoning. So that's kind of the big upshot of the development graphic, is to help teachers realize what the different sophisticated levels are, and that we need to be building that level of reasoning.
Interesting. And, John and I both have taught many of the same courses. And one course in particular, anyone from Ontario who has taught a grade 9 applied or a grade 9 academic course, oftentimes I think what you're saying, just for someone who's been in the classroom, and I'm hearing and I'm picturing the scenario of a student in my class that is even using additive thinking sometimes to solve proportional problems. So for example, a student building out a table and not even really respecting the fact that that's actually this ratio table that we're working with, and we're actually just like adding up and down, which is an effective strategy at times, right? It might be a very efficient strategy depending on what the question's asking. But if that's where that student is always, and we're not sort of like giving a little bit of that nudge to that multiplicative reasoning, helping them to see some of those connections through their own thinking, like eliciting their work and helping to nudge that forward through our consolidations in our lesson, it is so important. And for John and I, we actually have what we call a roadmap to proportional relationships that myself and some other colleagues, including Yvette Lehman, have spent a lot of time working around, and really they coincide so nicely. And I know for you actually have an online course built around proportional relationships and proportional reasoning. John and I both have one as well inside of our academy. And honestly, I look at both and I see such value in both. So for those who are listening and are really wanting to dive in, definitely check out both. I love, Pam, how yours is all nested. Mine is sort of the way it's lined up. It sort of looks like a bit of a continuum style, but all in all, they are attempting to do the same thing, which is helping people to move their own understanding a little further along as to what it is that we want students to be able to do with the mathematics, and where we want them to get to with their own reasoning and their ability to problem solve. And essentially to be able to notice and name where their students are so they can help them along as well. So at this point, I'm looking at the time, Pam. We have had a blast. John, what else do we have to ask? Something really important for Pam here.
Pam, if it's okay with you, we would love to put that image of your graphic on the show notes page. Would that be okay?
Yeah, absolutely.
All right. So we'll throw that on there, plus all the other links that we've talked about and resources that we've talked about here on the show notes page. Pam, where can our listeners go, say, to learn more about you or get more learning from you? Where can they hit us up with some resources that we can also add to the show notes page that our listeners can learn more about you and learn more from you?
Yeah, absolutely. And I love to connect. So I would love to see you on our Math Strat Chat. We launch Math Strat Chat every Wednesday evening. I throw out a question. People from all across the world throw in their strategies, explain their thinking. I try to interact as much as I can on Wednesday and Thursday. Honestly, I leave it alone a little bit after that. We're just starting a brand new part of Math Strat Chat where we're taking strategies that people put out on Twitter, Facebook, and Instagram, and we're kind of compiling some of the top 4 or 5 strategies that we saw, and then we're letting people vote on which one they like the best. The vote is less important, but the cool part is that what we're doing is naming strategies, and we're kind of putting them in categories. So people are then better able to kind of go, oh, okay, this strategy is different than that strategy, even though they were both on a ratio table. I see how they were using different relationships. So we're kind of helping people categorize, like getting better at those major sophisticated strategies for each operation. So we'd love to see you on Math Strat Chat. You don't have to join us Wednesday nights. You really can look kind of anytime, either Facebook, Instagram, or Twitter for that. And then mathisfigureoutable.com. If you can sign up for my weekly newsletter, my emails are actually planned out. They're teaching emails. In a lot of the emails, I actually teach something about the development of mathematical reasoning or models versus strategies or all sorts of things. So if you're interested to connect with me that way, you can find that on the homepage is at mathisfigureoutable.com. Like you guys said, I'm also developing online workshops. The first one is on developing proportional reasoning, but I've got several planned that will be coming out soon. And last but not least, we also have material for professional learning communities. If you meet in PLCs and you'd be interested to have really good material for you to study in your PLCs, then check out the product that we'll be launching this fall of 2020, all about material for PLCs. And there's a few books out there too. If you're interested, you can find them on my website.
Fantastic, Pam. It has been a pleasure. I can't believe how fast the time has flown. We actually had more questions for you, which means I think you're going to have to make a repeat appearance on the podcast, if that's okay with you.
I would be honored.
Awesome stuff.
Thanks so much, Pam. We hope you have a fantastic evening, and we will catch up with you either online on Twitter or in person at an upcoming conference.
Great. Thanks, guys.
Take care.
We want to thank Pam again for spending some time with us and the Math Moment Maker community while she shared so many insights with us and you at home on our Making Math Moments That Matter podcast.
As always, how will you reflect on what you've heard and learned from this episode? Because we all talk about some big ideas, but have you written anything down? Did you send out a tweet? Have you called a colleague to talk about this particular episode? Have you shared your learning in a PLC group? Be sure to engage in some form of reflection to ensure that the learning you did here sticks with you.
And before you leave, we know you're clearly interested in getting kids leaning in during your math lessons with the goal of building conceptual understanding, number fluency, and flexibility.
How do we know? Well, you're listening to a math podcast, of course. Want to take a deep dive into the Make Math Moments 3-part framework? Download the 3-part framework guidebook by visiting makemathmoments.com/framework.
In this downloadable ebook, you'll be able to take the learning with you as you build your own understanding of how you can spark curiosity, fuel sense-making, and ignite your teacher moves in all of your math lessons.
Go ahead and grab it now by visiting makemathmoments.com/framework. That's makemathmoments.com/framework.
In order to ensure you don't miss out on new episodes as they come out each week, be sure to subscribe on iTunes or on your favorite podcasting platform.
Also, if you're liking what you're hearing, please share the podcast with a colleague and help us reach a wider audience by leaving us a review on Apple Podcasts and tweet us your biggest takeaway and tag us at Make Math Moments on Twitter or Instagram.
Show notes and links to resources from this episode can be found at makemathmoments.com/episode 71. That's makemathmoments.com/episode 71. Well, Math Moment Makers, until next time, I'm Kyle Pierce.
And I'm John Orr.
High fives for us.
And high fives for you.